The author remembers the time when he was a student himself, a somewhat ambitious student, eager to understand a little mathematics and physics. He listened to lectures, read books, tried to take in the solutions and facts presented, but there was a question that disturbed him again and again. Yes, the solution seems to work. It appears to be correct, but how is it possible to invent such a solution? Yes, this experiment seems to work. This appears to be a fact, but how can people discover such facts? And how can I invent or discover such things by myself? Today, the author is teaching mathematics in a university. He thinks or hopes that some of his more eager students ask similar questions, and he tries to satisfy their curiosity, trying to understand not only the solution of this or that problem, but also the motives and procedures of the solution, and trying to explain these motives and procedures to others. He was finally led to write the present book. He hopes that it will be useful to teachers who wish to develop their students' ability to solve problems, and to students who are keen on developing their own abilities. Although the present book pays special attention to the requirements of students and teachers of mathematics, it should interest anybody concerned with the ways and means of invention and discovery. Such interest may be more widespread than one would assume without reflection. The space devoted by popular newspapers and magazines to crossword puzzles and other riddles seems to show that people spend some time in solving unpractical problems. Behind the desire to solve this or that problem that confers no material advantage, there may be a deeper curiosity, a desire to understand the ways and means, the motives and procedures of solution. The following pages are written somewhat concisely, but as simply as possible, and are based on a long and serious study of methods of solution. This sort of study, called heuristic by some writers, is not in fashion nowadays, but has a long past and perhaps some future. Studying the methods of solving problems, we perceive another face of mathematics. Yes, mathematics has two faces. It is the rigorous science of Euclid, but it is also something else. Mathematics presented in the Euclidean way appears as a systematic, deductive science, but mathematics in the making appears as an experimental, inductive science. Both aspects are as old as the science of mathematics itself, but the second aspect is new in one respect. Mathematics, in statu nascendi, in the process of being invented, has never before been presented in quite this manner to the student, or to the teacher himself, or to the general public. The subject of heuristic has manifold connections. Mathematicians, logicians, psychologists, educationalists, even philosophers may claim various parts of it as belonging to their special domains. The author, well aware of the possibility of criticism from opposite quarters and keenly conscious of his limitations, has one claim to make. He has some experience in solving problems and in teaching mathematics on various levels. The subject is more fully dealt with in a more extensive book by the author, which is on the way to completion. Stanford University, August, 1 or 2, 1944. from the preface to the 7th printing. I am glad to say that I have now succeeded in fulfilling, at least in part, a promise given in the preface to the 1st printing. The 2 volumes, Induction and Analogy in Mathematics and Patterns of Plausible Inference, which constitute my recent work, Mathematics and Plausible Reasoning, continue the line of thinking begun in How to Solve It. Zurich, August 30th, 1954. Preface to the 2nd edition. The present 2nd edition adds, beside a few minor improvements, a new 4th part, Problems, Hints, Solutions. As this edition was being prepared for print, a study appeared, Educational Testing Service, Princeton, New Jersey, CF, Time, it's probably Time magazine, June 18, 1956, which seems to have formulated a few pertinent observations. They are not new to the people in the know, but it was high time to formulate them for the general public. Mathematics has the dubious honor of being the least popular subject in the curriculum. Future teachers pass through the elementary schools learning to detest mathematics. They return to the elementary school to teach a new generation to detest it. I hope that the present edition, designed for wider diffusion, will convince some of its readers that mathematics, beside being a necessary avenue to engineering jobs and scientific knowledge, may be fun and may also open up a vista of mental activity on the highest level. Zurich, June 30th, 1956. Contents. From the printing to the 1st edition, from the preface to the 7th printing, preface to the 2nd edition, How to Solve It list, Introduction. Part 1. In the classroom. Purpose: 1. Helping the student. 2. Questions, recommendations, mental operations. 3. Generality. 4. Common sense. 5. Teacher and student imitation and practice. Main divisions, main questions. 6. 4 phases. 7. Understanding the problem. 8. Example. 9. Devising a plan. 10. Example. 11. Carrying out the plan. 12. Example. 13. Looking back. 14. Example. 15. Various approaches. 16. The teacher's method of questioning. 17. Good questions and bad questions. More examples. 18. A problem of construction. 19. A problem to prove. 20. A rate problem. Part 2. How to solve it. A dialogue. Part 3. Part 3. Short dictionary of heuristic. Analogy, auxiliary elements, auxiliary problems, Bolzano, bright idea. Can you check the result? Can you derive the result differently? Can you use the result? Carrying out. Condition, contradictory, corollary. Could you derive something useful from the data? Could you restate the problem? Decomposing and recombining. Definition, Descartes. Determination, hope, success. Diagnosis. Did you use all the data? Did you know a related problem? Draw a figure. Examine your guess. Figures. Generalization. Have you seen it before? Here is a problem related to yours and solved before. Heuristic. Heuristic reasoning. If you cannot solve the proposed problem. Induction and mathematical induction. Inventor's paradox. Is it possible to satisfy the condition? Leibniz. Lemma. Look at the unknown. Modern heuristic. Notation. Pappus. Pedantry and mastery. Practical problems. Problems to find, problems to prove. Progress and achievement. Puzzles. Reductio ad absurdum and indirect proof. Redundant. Routine problem. Rules of discovery. Rules of style. Rules of teaching. Separate and various parts of the condition. Setting up equations. Signs and progress. Specialization. Subconscious work. Symmetry. Terms old and new. Test by dimension. The future mathematician. The intelligent problem solver. The intelligent reader. The traditional mathematics professor. Variation of the problem. What is the unknown? Why proofs? Wisdom of Proverbs. Working backwards. Part 4. Problems, hints, solutions. That's problems, hints, and solutions.